Dhaka Higher Mathematics 2017, question number 6. In question number 6, the vertices of a triangle ABC are A, 1, 3, B, -1, -1, C, 3, -1, and the midpoints of AB and AC are D and F. In part A, determine the slope of AB. Now to do this, we can use the gradient formula. The gradient is equal to y2 minus y1 all over x2 minus x1. Now in this particular case, x1 is 1, y1 is 3, x2 is -1, and y2 is -1. So the gradient is -1 take away 3 over -1 take away 1. So the gradient is -4 over -2, which gives an answer. The gradient is 2. Now for part B, we're trying to find the length of each side and the area of the triangle ABC. Now we can use the length formula, which is the length is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now if we're taking the points A and B, x1 is 1, y1 is 3, x2 is -1, and y2 is -1. So the length AB is equal to the square root of -1 minus 1 all squared plus -1 minus 3 all squared. So the length AB is the square root of -2 squared plus -4 squared, which is the square root of 4 plus 16, or the square root of 20. And if we work that out as a length, the length AB is 4.4721, or rounded off, AB is 4.47. Now, since B and C have the same y coordinates, we can easily work out the length BC. It's simply the difference of the x coordinates. So the length of BC is 3 take away -1. So BC is equal to 4. Now to work out the length of AC, we have x1 is 1 and y1 is 3, x2 is 3 and y2 is -1. So the length AC is equal to the square root of 3 minus 1 squared plus -1 minus 3 squared. So AC is equal to the square root of 2 squared plus -4 squared, which is the square root of 4 plus 16, which is the square root of 20, which is again 4.4721, or if we round it off, the length AC is equal to 4.47. Now, to find out the area of the triangle, one way to do it is to use matrices. So we draw out a matrix and we put the coordinates of the points into the columns. So the columns are x1, y1, x2, y2, x3, y3, and we repeat the first point, x1, y1. So if we put in the numbers for A, B, C, and A, we get 1, 3, -1, -1, 3 -1, 1, 3. We then take the columns a pair at a time and sum their determinants. The area is half that sum. So the area starts off with 0.5 times, and then we take the first pair, 1 -1, 3 -1, and work out its determinant. That is 1 times -1, take away 3 times -1. Then we take the second pair of columns and work out the determinant. That is -1 times -1, take away -1 times 3. We then take the third pair of columns and we work out the determinant. So that is 3 times 3, take away -1 times 1. Now all of that simplifies, so we get the area is equal to 0.5 times -1 plus 3 plus 1 plus 3 plus 9 plus 1. So the area is 0.5 times 16, or the area is 8. Now actually, if we'd looked at the diagram, we can see the triangle has a base of 4 and a height of 4. The area of a triangle is half the base times the height, so it's a half of 4 times 4, which is a half of 16, which is 8. An easier way of doing it. Now in part C, we have to prove, with the help of vectors, that the line DF is parallel to the line BC, and the length DF is equal to half the length of BC. Well, to solve this, we look at the diagram. In the diagram, we can see going from B to C is the same as going from B to A and then A to C in terms of vectors. So the vector BC is equal to the vector BA plus the vector AC. Now, in terms of vectors, going from D to F is the same as going from D to A and then A to F. So the vector DF is equal to the vector DA plus the vector AF. But vector DA is equal to a half of vector BA, and also vector AF is a half of vector AC. So DF is equal to a half of vector BA plus a half of vector AC, or DF is equal to a half of vector BA plus AC, just factorising. But BA plus AC is BC, so vector DF is equal to a half the vector BC. Now if one vector is a scalar multiple of another, they're parallel. So DF is parallel to BC. And also, if one vector is half the other vector, that means its length is half the other vector. So DF is equal to a half of BC.